A frequency table is a list of outcomes in a sample space, and the frequency, so the number of times each outcome occurs. So a simple outcome I could think of is if you're tossing a coin, you can either have heads or tails. So let's say you toss a coin twice. So you could have, the outcomes are you could have heads, you could have heads, two heads, that would happen once. You could have one heads and one tail, that could happen twice. Or you could have two tails, so that could be twice. So this would be the frequency is the number of times it occurs. And this would be, why did I just put two tails once? So two tails once. And this would be the outcomes that you could have. So if you think of a tree diagram, you could have heads. The first coin and the second coin could be heads or tails. You could have tails on the first coin, and the second coin could be heads or tails. So that's how you could get heads, heads once, tails, tails once, and then tails, heads twice. A probability distribution is a function that gives the probability in a sample space. We'll do examples down below. So use a frequency table to find each probability. See how you have something, this would be your domain, and this would be your range. So it's definitely a function, so for each domain there's one unique range. So what is the probability that a person alone is 45 or older? So here's 45 and older. So to find the probability, what I'm going to have to do is I'm going to pause it and I'm going to add up all of these numbers to get my total outcomes. So total, we have 26,605 people. So if I want the probability that a person living alone is 45 or older, I'm going to add up this number plus this number and take it out of 26,605. So I'm going to add 7,757 plus 9,747, which is 17,504, and divide it by this sum right here, which is 26,605. And so that is approximately 66%. I rounded. You could leave it as a percent or you could leave it as a decimal. And then B, find the probability somebody is 15 to 24 years that's living alone. So right here. So I'm going to take 1313 and divide it by 26,605. And I'm going to get 4.9%, or approximately 5%. And then 65 or older is going to be 9,747 divided by 26,605. And I get about 37%. So this is a frequency table. It doesn't show the probability, so it's not a probability distribution. And that's going to be at the bottom of the sheet. So this one, take a survey. We don't really need to do that for your classmates, but so what you would do is you would write down the number of times somebody said brown was their eye color. And then number 3, we're going to organize this into a frequency table. So a survey of student preferences showed that 43 students preferred cheese, 56 preferred sausage, 39 pepperoni, 28 supreme, and 31 another kind, and 19 did not take any type of pizza. So organize the frequency table. So I'm just going to list off cheese is 43, sausage is 56, pepperoni is 39, supreme is 28, another kind is 31, and no pizza or no type of pizza was 19. So let's see if I got them all. So I got cheese, 43, 56, 39, 28, 31, 19. Okay. So I'm going to just, I know I'm going to want to add this up if want to find the probability distribution. So I'm going to add up 43 plus 56 plus 39 plus 28 plus 31 plus 19. So 216 people we're talking about is total. So graph the probability distribution. So this is when you're asking, okay, what's the probability that a student picked cheese? So the probability is 43 out of 216. So 43 divided by 216 is 19.9%. So first I'm going to fill in these percents down here. Sausage is 56 divided by 216, 25.9%. Pepperoni, 39 divided by 216, 18.1%. Supreme, 28 divided by 216, 12.9, or actually round up to 13, so 13.0%. Another type is 31 divided by 216, is 14.4%. And then none was 19 divided by 31, 61.3%. So these are all percent. So to graph a probability distribution, what you want to do is you make a graph like you're in the first quadrant, because we're talking about positive probabilities. And then I'm going to label my x-axis. So I'm labeling my x-axis as type pizza preferences. So I'll put pizza preference down here. And then I'm going to put cheese, sausage, pepperoni, supreme, other, and none. And then up and down, this is going to be your probability. So your probability is based on the different probabilities that you have right here. So if I'm thinking of a scale, I'm going to go, I could start at 0, and I want to make sure I get all the way up to, that was not 61. Oops, I should have divided 9. I did, this one was, that's kind of weird. I should have noticed that right away. So this was 19 divided by 216. So this is 9%. Or actually 8.8%. Okay, so I'm going to think about, I need to make sure my scale maybe goes up to 30. So I'm just going to go 10, 20, 30%. So here's 30%, and I'm going up by 10. So now I just do cheese is 19.9%. So it would make a bar graph almost to 20. Sausage is 25.9, so a little more than halfway. Pepperoni, so you're just basically doing a bar graph of the different probabilities. Pepperoni, supreme, other, and none. So that's what a probability distribution is.